chapter. So I have we only have, I think, around 3 weeks left of classes. I'm not so sure if ilan yung i-extend, but according to the calendar, classes will end at around December 8th. So December 8th is Sunday. So on the first week of December. And examination period is on December 9 to 14. So that's the final examination period. And the submission of grades is on December 28th. So most probably we will be conducting our final exams on 9 to 14. And with that, we need to finish, I think, around 3 topics. So we're already done with algorithms. So hopefully, nakasabot mo ato, no? It was unfortunate that you were not able to utilize the laboratories, no? But it's okay. Sige lang, makalabraman mo sa inyong actual nga mga programming courses. So, then we have, I think, relations, combinatorics, and I don't know about the last topic. So, we have around 3. So, I think kaya naman siya. Okay, so, yes, so mo to siya, just a heads up as to the remaining time that we will have. Alright. So, as for the kaning evaluation, if ever nakasabot bagid mo sa algorithms, no, I will be conducting, I think, a long quiz this Monday. If we will be able to finish relations this class karon, then I think magkanda ko og just not a long quiz, but more of like just to check if nakasabot mo sa klase so far. Okay, so I think it would be scheduled on Monday. Okay, so including na this topic. Or maybe algorithms na lang sa. So, siguro sa Monday na lang. Okay. Okay, so yes, I'll be announcing ang sa manggani ako ma-decidean sa GC. Alright, so we will be talking about relation, diagrams, and function. This is a mouthful because in the book that I am basing this, relations and functions are 2 separate chapters. So relations is a separate chapter, functions is a separate function, and in this course, they are fused together into just one topic. Functions supposed to be is you should have prior knowledge in algorithms in tackling functions here, because I think some of you might be aware na sa inyong programming na that we have functions as well there in your programming courses. So it's similar to this, no? So now let's talk first about relations. Sige. Okay, so this meeting is recorded, so you can visit this anytime. It will be uploaded on my YouTube. So, pwede rin ito ninyo tanawan subject to, no? Bear with me. This is the first time I'll be teaching relations no, sa klase, because these were not included on the CSC 102 topics. Last time I was teaching this course. So, anyways, saan siyang relations? Actually, the kaning statement is not practically the definition. It's more of like describing what relations is. So, they are there, relations are there. So, consider the existence or non-existence of certain connection between pairs of objects taken in a definite order. So, technically, if we relate this on data and computers, no, there's always relations. Relations between the data you have, relations between your variable and what you will do to it. Relations, everything has a relation. I will not define this because we all know what relation is. It's like a relationship between object, no? This can also be related to persons, no? Relationship between people. Relationship, something that there is a connection between those objects, no? So that's relations. Okay, so the most common or the most kanang pinaka uh, not sa term ano, inyuhan ng na-experience, of course, is kaning ordered pairs. Ordered pair, since nag-algebra mo, you already know what ordered pair is. Ordered pairs are relations, no? So, ordered pairs of element A and B, where A is designated as the first element and B as the second element, in particular, A, B. So, ordered pair is important because their order is important. No? Okay, gibalik na ako term. It means that if A comes first in a relation, A will always comes first, then B after. Okay, so if first element's A, then A should be what is written first in your ordered pair and B the second. So technically, their places in the pair is important. Okay, so it says here that two ordered pair are equal if and only if A and C, A is equals to C and B is equals to D. That's the only time that these two ordered pair are equal. You cannot state that these two ordered pair are equal if nagkabali-bali ang ilang order. Like for example, sa first ordered pair AB and then the second ordered pair is BA, then of course that is not equal unless if A and B are equal. So, nakabutang siya din. Okay. So, muna na siya, no? So, where the order of elements is irrelevant. For example, okay, so ordered pair are different from sets. You should be aware of that, no? Sets, pwede rin magkabali-bali, but from the term ordered pair, hindi sila pwede magkabali-bali. Now we have what you call the product set. So you already know this one. So say for example, you have two arbitrary sets A and B. The set of all ordered pair AB, where A is from, of course, A and B is for B. So it's called the product. Okay, so I'll be explaining that one. Okay, so it is said that if you have an ordered pair AB and A is from set A and this B here is from set B, then the sets that they came from can be considered as your Cartesian product of that set. So, muna siya ang iyang formal definition of that. So, if this two, your ordered pair, is from the same set, then you can say that it came from A squared. So, this is kung pareha sila gigikanan, no? So, anyways, product sets ang tawag ana niya if kani, for example, small letter A came from big letter A and small letter B came from big letter B. So, kani sila is considered a product set because they're joined by their element. Okay. An example of that is your Cartesian product. No? So you have a set of y and then a set of x joined together with a point or Cartesian plane. The term ano niya. So this P here is your ordered pair starting with A and your B. So technically, this here, since this is your x-axis contains all real numbers and your y-axis contains all real numbers as well. So we can say that the geometrical representation is r squared. So r squared ang entire sets, this one, because this is r, this is also r, and they are joined together with the ordered pair. So the entire set that came from kanini P is called the r squared. Okay? So, muna siya, no? Muna makabantay mo na sila ginamit ang r squared. Alright. So, example is we have here set A that contains 1, 2, and set B that contains ABC. So if we perform product or partition, okay, if we multiply A and B, two sets, no? Muni ang equivalent niya nga mga relations. So, it is important to note na different ang answer ni A times B o lahi po ang answer ni B times A. Okay? So, if you say A times B, it's all the elements of A multiplied by each element B, or paired by, not multiplied, paired by all elements of B. So, 1A, 1B, 1C. And then we have 2A, 2B, 2C. Okay? If we switch that the other way around, B times A, it is the multiplication of the pairing of A1, B1, and C1, and the rest. Now, if you look at this, ma'am, pare-pareha naman niya siya, nagkabali-bali lang, no? Now, note that this is an ordered pair. So, it's important to note ang unang nga pair o ang sunod na pair, dili pwede magkabali-bali. That's why A times B is not the same as B times A. So, if we want to multiply A by itself, muna ang iyahang combination. Okay? So, this is what I mentioned. A times B is not equals to B times A. And if you wanted to know the number of elements that could be produced or the number of pairs that could be produced if atong i-product si A of B, it is equivalent to the number of element in A times the number of element in B. So, say for example, this one, so we have 2 elements in A and 3 elements in B. So, of course, their answer is 6. So, the number of pairs that could be produced when multiplying these two sets is the number of elements in A times the number of elements in B. So, thus, 6. Okay. So, atong i-zoom gamay. Ma-zoom ba na siya? Okay. So, let A and B be sets. A binary relation or simply a relation from A to B is a subset of, okay. So this is how we write relationships, no? So suppose R is a relation. So we can actually name relations. It's up to you. You can name your relation whatever letter you want. So in this book, ang iyang pangalan sa iyang letter is, as iyang letter, sa iyang relation is R. So we can then state this one, AB is an element of this relation, this one, such that A is related to B. So it can be written as A or B, no? Wherein kaning R is the name of your relation. Okay? So, sige. Then R is a set of ordered pair where okay. So, muna siya, no? If A is not related to B, so we can just simply say A R slash B. Okay. So, ano lang, no? So, technically, this atong klase ron is more on the terms, no? More on the common terms used in relations and some knowledge about relations. Okay. Okay, so if R is a relation from set A to itself, then that is if R is a subset of, and we say that R is a relation on A. Okay, so say for example we have a relation R, and then all of its element R comes from A, then we say that R is a relation on A. So technically that relation only exists in A. Okay? Alright. So, side note lang na siya. So, example. Sige, muna natin talaga example. So, you have here two sets. A is equals to 1, 2, 3. B is equals to X, Y, Z. and let R be 1y, 1z, and 3y. So if R is a relation from A to B, okay, so relation siya ni A to B, and since R is a subset of A times B with respect to its relation, so okay, so ang ani na siya, you have two sets, si A ug si B, and you are given this relation set. So technically, this relation, if you look at this carefully, all of its first element is from A, and all of its second element came from B. So we can safely say that it is a relation from A to B. Okay, since first element pa ng A, second element si B. And then we can safely assume also that R is a subset of, okay, so for a while lang. Okay, medyo saba akong palibot. Okay, so don't worry, this class is recorded. Okay, so wait lang.
Sir, two-way picture sa ako. Photocopy sa over CR o photocopy sa reverse license. Tapos na rin. Naka-form ulit mo. Magbayad lagi si Quinta sa cashier. Actually, maglako-lako ka ata. Dili pa. Kailangan namin assessment.
Yan sa kuan.
Ikan
Ikaw
ka
sa ano.
security.
Ano pa ka dito, ma'am? Kung may ka naman yung mga para dito sa security, ma'am.
Okay, okay. Sige na lang. So bear with me. My environment is very noisy. So with respect to this relation, we can say that this one, A, is in relation to Y, and 1 is in relation to Z, and 3 is in relation to Y. Okay? So that's the only relationship that we have given the R. So we cannot just assume na si R is relationship ni 1 is relationship ni X, no? Kanira man ang gihatag na set ni R. So these are the only sets that are in these are the only member of the sets ni A and B that are in relationship. So kung mag-uyab pa ni kanisi kaning mga girls, kani ang mga boys, no? So kani si boy here, do kabuk ang uyab si 1 ug si 3. So anyway, that's the only allowable relation na na-state because we already set R. So in other words, we cannot just assume na kay relate man si 1 ug Y diri related na pud tanan A kang B. No, dili. So it's really up to what is really inside your relation R. But since R contains A and B, no, it is safe to assume that R comes from the set A times B. Okay? Alright. So the domain of R is 1, 3. So that's when you say domain, that's the first element of your pair. So the first element of your pair is just 1 and 3, and then the range of your pair is the second element, which is the Y and Z. So technically, in example A, it's just ni-state lang siya din niya as to how to describe a relation and sa iyang domain and what is the range. Alright, second is set inclusions. This one, subset, is a relation on any collection of set for given any pair of set A and B. Either A is a subset of B or A is not a subset of B. Set inclusion is a relation. Okay. So, this one, kanya siya, it just states unsa nga klaseng relations will occur with this operation here. This is just a subset, no? So we can say that given a pair of set A and B, we can assume that A can be a subset of B, so there could be a relationship between A and B or not, no? So ako na lang, that's just an example of relations. The third is a familiar relation on the set Z, so integer ni siya, is M divides N. A common notation for this relation is to write M divides M. Okay, so this is also a sample of a relationship, no? That is a relationship of two numbers M and N such that they are connected with the kaning relation named divide. The divide here is kato inyong murag R, but it has a ashay method involved. So divides just mean n can be divided by n. So muna siya. But M and N are related using this divides na relationship. So you can write this 6 as relates to 30 or 7 not related to 25. So it's like that. So 6 can be used to divide 30, so these two are related, but 7 cannot be used to divide 25. It's like that. So still, this is a relationship na partnership. Also, the divide here, kaning divide is, ano na siya class? Will hunt you. Will come back and hunt you on your CSC 103. So, sige lang, mabalik rin sa divides. Now, another set of relationship is considered a set of L in plane perpendicular. So you have a plane L, and then you have a pair of lines A of B. So A of B can be perpendicular to each other or not. This is still an example of a relationship. So where A relates to B, wherein your relates term is the perpendicular term. Okay? So, similar to parallel, no? So, ano siya? Let A be an dito sa E. So, let A be an set. An important relation in A is that of equality. This one. So, okay, so muna to siya. This is just an example of relations in the wild. So, when you makita nga relationship in algebra, in geometry, so mo na siya. So basically relations are everywhere, especially on computer science, on data as well. Manipulate data in the future, those here are relations. Okay. Now let's go to the inversion of this relation. Okay. Let R be any relation from set A to set B. So the inverse of R is denoted by R here to the power of -1 is the relation from B to A, which consists of those ordered pair, which when reverse belongs to R. Okay, so in ani na siya. Inverse is just kita na may ginagawa. So inverse is just kanang gibali lang, no? Like for example, this one here. Your R is the relation between A and B, right? So you can say AY, AZ, 1Z, and 3Y. So this is a relation of A and B. So if you inverse this one, you're just gonna balihon lang. So instead of 1 ang una, i-Y ni mo ang una, and then 1 here. So they are technically just the inverse of each other. Okay, so that's what you call the inverse relation. So if I'm going to ask you the inverse of, say for example, the relation S, no? Then you're just gonna be finding out and say na anang S and then inverse it. Okay, now let's go to the pictorial representatives of relation. So technically, relations can be presented pictorially para makita natin siya, no? In a way. So we have here x squared plus y squared is equals to 25. Its center is at radius 5. So this is actually a relation, no? Where your your relation is the value of your x and y. So if you graph this one, so muna yeah. Okay, so just a simple example lang na siya. Okay. Okay. Another is this one. You can use you can use directed graph. So on sending directed graph will hunt you again. Kani actually si CSC 102 again I will mention it's like an introduction to all computer science courses. So na diri halos tanan ninyong makita in the future, no? So directed graph is a graph that represents relationships, no? From one point to another or from one data to another. So, say for example, you have a set R here, and this is your R. Now, these are all the relations that you have 1, 2, 2, 2, 2, 4. To create a directed graph of this set R, no, you first write each of the element unsa ni siya nga set gikan. So in this case, all of the element in R came from the set A. So ato siyang gibutang sa circle ang katong mga element. So we have 4. And then we write a line from the first element to the second element of your relation. So from 1 to 2, from 2 to 2 itself, from 2 to 4, then from 3 to 2, 3 to 2, and then 3 to 4, and so on and so forth. So technically, the directed graph of this set of relation looks like this one. Now, where can you use this one? Okay. In the future, you will be introduced with what graph is. Now, graph is one of the most fundamental data structures in computer science. It is used to solve many problems, including networking, databases, artificial intelligence, games, Minecraft, Mario games, whatever that includes data points, no, is found in graphs. So technically, this is just a little introduction as to how you can present a graph, no, with the relation that you have. So, inga na siya. Now, directed graph. This is called a directed graph because as you may have noticed, there is an arrow from 1 to 2. So, na ay direction on each of the arrows that you can see. Now, there are graphs that doesn't have an arrow. So, they are called undirected graph. Wala na siya din sa to ang slides. Undirected graphs are those types of graphs that really doesn't have any direction at all. Lines lang ang inyuhang makita. So, from 1 to 2. So, technically, those are still relations, but technically, they are not ordered there. So, dili siya ordered. No? So, ngano wala ang 1, 3? Walay 1, 3 because there is no relationship here na makita na to sa RCEP na na-connect si 1 and 3. Okay? So, muna siya, no? So, this is an example of directed graph. We have an undirected graph, but since we're still talking about ordered pairs, so directed graphs lang sa ta. And we also have that what you call weighted graph. So each of the line here na sila weights. So the relationship between two pairs are dictated by a weight, a value. So say for example, 1 and 2 has a relationship value of say for example 10 compared to 2 and 2 has a relationship value of say 2. So meaning the relationship value of 1 and 2 are much stronger compared to 2 and 2. So, anapoy ana. no? So it can be represented as a weighted graph. But as for now, directed graph lang sa to use we use on representing relations. Okay. So there are also other ways to show relationship. You can use matrix, this one here. So this is the most efficient way to show a relationship between two um, elements in a computer. Because technically, kung mag-drawing ka gingani sa computer, hindi siya possible sa computer, yun mo siyang i-translate, ipasabot si computer, dili maka-drawing si computer, no? Again, computers can only understand one and zeros. So, usually to represent relationship in computer data, we use matrix. So, this one here, it just means na butangan ninyo 1 if there's a connection between this pair. So, say for example, si 1 and si y has a connection, then you put there 1. C1 and X does not have any connection, so you put there 0. C1 and Z does not have a connection, so you put 1, and so on and so forth. So this is the most effective way to show a relationship digitally. Okay, computer. This one is another way of showing. So this is what you call the arrow diagram. So arrow diagram is one of the most straightforward ways to look at a relation of two sets, no? So unlike the directed graph usually involves one set. So one set lang na siya. So if there's relationship between elements that came from the same set, then you can use directed graph. However, if the relationship came from two separate or two or more sets, then it is much more effective to show them using the arrow diagram. Because in this way, makita na to ang relationship between sets na. Okay? So here we can see na set here, kanisya si set A is related to set B in a way that it connects 1 and 3 to X, to Y, and Z here on your second set. Okay? Now, if you have two sets, I will discourage using directed graph because directed graph does not really show the relationship of sets. It shows the relationship of the relations, no? Kani nga mga element. Mura ang iyahang pakita. In this one, you can really see the connection sa dual sets. Okay? So, that's how you represent relationships. Okay, so compositions of relations. Okay, so technically, there is also what you call the marag katong sa logic. If A, then B, if B, then C, then we can say that A is C. No? It's like this one. No? So, say for example, you have three sets, A, B, or C. And then you have a relation from A to B, R, and you have a relation S from B to C. And then R here is kanisya, of course, is a subset of A times B, cross B, and S is a member of B cross C, then we can safely assume that there could be a relationship between A and C. Okay? So, with that, we can say that A and C can be connected using R.S. So, this is how you write that one. Since two relationships are involved in connecting data from A to C, which is R and S, you write it this way. Okay? So, R dot S, where B is an element of B, and then A is related to B and B is related to C. So example of that one, the example, yes, this is one of the example. So so that one here. So you have two sets, 1, 2, 3, 4, and A, B, C, D, and three sets there, and X, Y, Z. And this is your relationship R, and this is your relationship S. Now, in drawing or in visualizing these sets, it is much more efficient if you use Ganesha because we are looking at the relationship of the sets involved. So this is your set A, this is your set B, and this is your set C. You put an arrow if you see a relationship between them. The relationship between A and B is called R. So you put R here. So meaning all the arrows here belongs to R. So 1A, 2B, and such. And open delete ka S. Now, here, sa kilid is the answer. No? Answer na siya. Um, kung tanaw na to, one of A na connection does not really relate to C here, so we cannot see any relationship with that one. 2, D, and Z. Dire, nakita relation from 2 to D to Z. So we can safely say that 2 can be related to C by writing in this form. So 2 R dot S Z. Okay, so technically it means that 2 and Z can be connected using the R and S connections, relations. Okay? Another is the 3 and X. No? So, ano siya? 3 and Z. And with this one, we can say that R dot S is equivalent to this set. So, 2Z, 3X, and 3Z. So, technically, the relationships that can be connected using the R and S are this one. So 2Z, 3X, and 3Z. So that's what you call composition of relation. No? Now, it does not really stop there. Pwede pa kang mo-add sa set diha, and another set, and more set, and more set. So, with that, you can write as many dot here, so on. Okay? Okay. So this is another way of showing a composition of relation using a matrix. So katong kaganina, gipakita na nato using yan, arrow diagram. So this is an arrow diagram. Now let's see how we can look at this one using the matrix. Okay? So this is the connection of R, relation of R. When I say connection, it's like maglibog mo ko sa relation of connection. Ako silang ma-interchange. So, this is the relation of R and this is the relation S. So, 1A is connected, so na sila 1. 3A is connected, so na 1, and so on and so forth. So, unsa ni siya pagtanaw so that we could come up with this one. Ang iyang term diri is like multiplication. So, if we multiply MR and MS, actually that's not the right term to use. I don't know why ganun pa rin yung term magigamit sa book because technically when multiplying two matrices, it should be that match ang ilang column kung ato ni inverse ang isa, no? Or if value wise ang pag multiply, it should be same sila dimension. So in this case, I think what the author meant about this multiplying is that looking into the data itself. So say for example, this one, 2D, here has a 1. So you look into D here, if naa siya connection to anything. So naa siya connection here, kang Z. So we can look at that at 2Z. So technically 2Z has a connection. So it's like looking at each of this matrix. No? So here, 1B. Ay, 1A, sorry, 1A. So tanan na to si A diri if na siya any connection. Na pa siya any 1. Wala. So meaning, wala. Next, si 2D na siya 1. Let's look at D here. Na siya 1 kang Z. So we can safely say 2Z here is connected. 3A, ano na to si A? Wala. So, wala connection si A there. 3B naa. So 3B tanaw ta kang B naa kang X ug kang Z. So we can put 1 here kang X. And then I think na 2 is C kay duha ka buka connection ni Z. 3. So you look at this one diha. So man siya mga 2 ni siya. Sa ing ato rai, isa na ninyo siya tanaw. No? So muna siya, no? Be, asa isang siya, asa ning isang connection? Si 4D, okay, si 4D. Si 4D, dili si 3D. So si 3D, tulog din niya yung connection. Si 3A, wala kang A dire. Si 3B, B na kang X ug kang Z. So butang pa diri 1 ug 1 na. And then 3D na which is kang Z. So may man ni din siya 2. Kuha ninyo. Kuha. Thumbs up. Okay. Si Daniel ra nakakuha. Okay. So yung ana ang na siya pagbasa. Okay. Okay, now let's look into a reflexive relation. So it says that a relation R on set A is reflexive if A are A for every A element of A, thus R is not reflexive. Okay, actually this one, ang definition ani is that reflexive just means if you have an R that is from the same set and that it relates to itself. Okay, mag-take ako example about that ha. So, here, natin example. Diri So, if you want to know if this relation is reflexive, it should come from the same set. So, it's a check already because the problem states na all the relationship here are from this set. A is equals to 1, 2, 3, 4. Okay, so if you look at that, yes, so it follows. Nagikan siya na ang set. Wala tayo nakita na 5 here, wala, 7, wala. So, from R1 to R3, R4 is an empty set, so it could belong here. R5 is, of course, 8. So, all of this conform to the reflexive na rule number 1, which comes from the same set. Another rule for reflexivity is that there should be a relationship here that relates to itself. So, say pasabot na. Dapat na yung nag-exist na relation nga 1, 1, 2, 2, 3, 3, and 4, 4. So, if a relationship set has those elements, then it is considered reflexive. So, let's look at this one. R1. So, if you look at that 1, 1, check. So, we need to find 2, 2. Walay 2, 2. 3, 3, wala pod, but it has 4, 4. So, R1 is not reflexive. R2, na ay 1, 1, na ay 2, 2, 3, 3, and 4, 4. So, this is considered reflexive. R3, this is not reflexive. Okay, of course, wala si 1, 1, 2, 2, 3, 3, and 4, 4. R4 is an empty set. Of course, this is not reflexive. And R5, this is reflexive already because in this set, mga to siyang isa-isang one, there exists a 1, 1, a 2, 2, 3, 3, and a 4, 4. So, technically, R2 and R5 are the only reflexive sets here given. Sakto ba akong answer? Yes. So, R2 lang and C, R5. Okay? So, again, when you say reflexive, you look at the sets and then try to find out if they come from the same set, and if na a relation that is related to itself. Okay. Now let's go to symmetric. So we only have 7 minutes left. Okay, sige. Alright. So, dirita sa um, reflexive. So, relation R on the set A is symmetric if whenever A are B and B are A. That is, if whenever element of R, then B A element of R. Okay, reflexive siya in a way, class, na um, sige. If 1 2 exists on R1, then there should be a 2 1 that exists as well. Di ba? Kuha ninyo ang iyan definition. Pasabot, if an R is reflexive, if na siya element na pwede na nabalik. So, kung na ay 1 2, this should also contain 2 1 for it to be reflexive. Ay, yes. Symmetric, sorry, not reflexive, symmetric. So here, 1 1, 1 2, this is 2 1, 2 2, 3 3, and 4 4. R2 is symmetric, no? Symmetric na siya. R3 is not symmetric. R4 is symmetric, I think. And R5 is symmetric. So here, R1 is not symmetric. R1 and R3 is not symmetric. The other relationship are symmetric. So si R1 at si R3 lang ang really symmetric. Okay, so again, symmetric are those katong relation na siya element na magkahalika. Sige, so now it's your turn. Shine. Okay. So I'll be giving you a set of relations, and then you will be identifying if those set is reflexive or symmetric. So reflexive is katong kaganina na contains itself, and symmetric is katong gingon. Okay? So for a while. Okay, so while waiting for the sige, na lang. Okay, we're really sige. So, na lang siya, class. Titibunan ako ang exam because meeting link has already been provided. Ika na sa amo ang meeting. For a while lang sa class, ha. I'm just gonna write, na lang, kaning attendance. So, today is November 14. Okay, just write your section lang ha because unfortunately this would man memorize on inyong section FG1, FGI1. So isulap na lang ninyo siya din sa inyong attendance. And then we have a proof of attendance. Just a screenshot of the meeting. And then I'll be sending this to you. Okay, any questions so far? Any question? Wala. Ano mo pangatana? Okay, Prince. Yes.
Actually,
Yes. What's your
excuse ko,
question?
kanang apil ba ang algorithm mo pagka Monday no?
Okay, so by Monday, we will be having a short quiz on algorithms. And then we will continue on our discussion with relations and functions. So technically, karong Monday, algorithms lang sa. And then when we're done with the relations, maybe next week, mag-quiz na punta. Okay, so
Okay ma'am, thank you ma'am.
sa Monday na siya. Okay, so attendance is already shared sa message, no? So, pwede na mo mag-attendance. And then, thank you for attending the class. This class is again recorded. You can visit this anytime sa YouTube. So, I'll be uploading this one. So, questions are very much welcome kung chat mo sa ako No, not just out. Ayun lang sa kanang gabi na pugayo or sa kadlawon. Okay? So, thank you everyone for attending the class. So, see you next meeting.